Hello everyone, my name is Keshvi Santoki and today I am going to discuss about satellite orbits. So let's begin. Introduction to communication satellites. Before understanding the orbits, first we should know what is communication satellite does. A communication satellite works like a repeater in space. It receives signals from an Earth station, amplifies them, and then sends them back to the other Earth station. Because of this, the communication is possible over the longer distances, even beyond the line of sight limit of the ground communication. So, communication satellite is basically a satellite does not generate information on its own. It only receives the signals, amplifies it, and retransmits it. This is why it is called the microwave repeater in space. Without satellites, long distance global communication would be very difficult. Satellites, orbits, and communication. Now let's understand the satellite orbits. An orbit is the path followed by the satellite around the Earth. According to the book Horizon, the choice of the orbit is very important because it affects the coverage area, signal delay, and number of satellites required. Quality of the communication is also the part of this. So while designing the satellite communication system, engineers carefully select the orbit. Now we are going to discuss about the geostationary Earth orbit, which is GEO. The most commonly used orbit for the communication satellites is the geostationary Earth orbits or GEO. A satellite in GEO appears stationary with respect to the Earth. That means it stays fixed over the same point on the equator. Because of this property, GEO satellites are widely used for television broadcasting, weather monitoring, and long distance communication. Geostationary Earth orbits means the fixed point. So let's discuss that. First is orbital altitude. Geosatellites are placed at the height of about 35,786 km above the Earth's equator. Second is synchronous rotation. They, they revolve, not rotate, around the Earth in the same time as rotation of the Earth, that is about 24 hours. Because both rotate together, the satellite appears in the fixed in the sky. Next is apparent fixity and the long range communication. Due to the synchronization, GEO satellites appear fixed at one point to an observers on the Earth. This makes them ideal for long range communication because they provide stable connection and continuous coverage. Key features of geostationary Earth orbits. One GEO satellite can cover almost one third of the Earth's surface. With the proper placement, just three GEO satellites can cover most of the populated world. They are used for TV broadcasting, intercontinental telephone links, for high data rate communication. Because they have appeared fixed, tracking is not required, which simplifies ground equipment. Advantages of GEO satellites: large coverage area, which is suitable for better broadcasting, stable connection link, communication link. Because satellite does not move, so they are stable communication link. Fixed position antennas, which reduces the cost. Widespread usage in the global communication system. What challenges, like what disadvantages of geo we are facing? That first, high latency, because geo satellites are the very far away. The signal delay is around 240 to 280 milliseconds one way. Second, this delay makes them unsuitable for real-time application like online gaming or video calls, which is very most important in today's generation. So it is not beneficial for this. Third, high launch cost, because placing satellite at such a high altitude requires powerful rocket also, so it is more costlier. Low Earth orbit, which is also known as LEO. LEO. LEO satellites are much closer to the Earth, between 160 to 2000 kilometers. They move very fast and do not stay fixed. Each LEO satellites cover a small area, so many satellites are required to form a constellation. Then also why GEO remains be preferred. Even though LEO has low delay, GEO is still preferred. But why? Simple ground station design, continuous coverage of region, excellent support of for broadcast services like TV. So that is why broadcasting a small delay is acceptable, but wide and continuous coverage is more important. So that's why we are using GEO. Satellite communication links. First is uplink. Signal is sent from Earth station to satellite. Uplink frequency is higher than the downlink frequency. Then downlink. Signal is sent from satellite back to the Earth. Satellite uses microwave frequencies because they support long distances, high data rate communication. All these are required like uplink, downlink, microwave frequency, and transponder. Transponder is also a very important part of this, as it is a satellite transponder receives the uplink signal, it amplifies and changes its frequency, and then it's retransmit and then downlink signal. So I can say that uh, GEO is preferred for broadcasting and long distance communication, while LEO is used where low and delay is required. That's all for satellite orbits. Thank you.